Hello, everyone. Welcome to Physics 205. This lecture is going to be on significant figures. So we'll discuss how to determine how many significant figures are in a particular quantity, and then also how to operate with those quantities, how to multiply and divide, and how to add and subtract, and have the result have the correct number of significant figures. Okay, so first, in general, the result of a measurement is known only to within a certain accuracy, and the number of significant figures in a physical quantity is the number of digits known with certainty. So, for example, let's say we're measuring the distance of something, right, which I'm calling d here. And let's say we record that value as 12.74 meters. So in this case, in this example, and I'll explain why in a minute, there's actually 4 significant figures. Like each of these digits is significant. So there's 4 significant figures. As another example, let's say I measure the time of a particular event, and let's say we come up with 2.3 seconds. So in this particular example, there will be 2 significant figures. So both of these digits, the 2 and the 3, are significant in this number. Okay, so what are the rules, the various rules for significant figures? So the first rule is that non-zero digits are always significant, right? So 1 through 9, those are always significant. The final or ending zeros written to the right of the decimal point are always significant. So if you have zeros written to the right of the decimal point, then they will be significant. So let me pause for a second here and give you a couple of examples on the iPad. Okay, so for example, let's say we have the number 3.7415. Okay, and I don't know, let's say it's on length, so it's in meters. So in this case, because all of those digits are non-zeros, they're all going to be significant. So in this example, I would have 5 significant figures. Okay, now remember, we also learned that if you have zeros and they're written to the right, they're ending and they're written to the right of the decimal point, those are also significant. So for example, if you have something, say 7.310. There's a 0 there, but it's written to the right of the decimal point, right? It's ending at the right of the decimal point. So it is significant. So in this case, I would have 4 significant figures. Okay, so each of these digits in this example are all significant, including that 0 because it's written to the right of the decimal point. Okay, so continuing with the rules. So rule number 3 is that zeros written to the right of the decimal point for spacing, right? If they're just used as placeholders, those are not significant. So if they're right after the decimal point, they will not be significant. I'll give you an example in a second. And then number 4, zeros written between significant figures are always significant. Okay, so again, let me jump back to the iPad and give you some examples of these. Okay, so for example, let's say I have this number, 0.0021. So in this case, these 2 zeros here are just placeholders. They are not significant. So in this particular number, only the 2 and 1 are significant. So this would be an example where there's 2 significant figures. Oh, and by the way, the 0 that's in front of the decimal is also not significant. This is also not significant. Okay, what about this? Let's say I have 2.7001. So now those two zeros are written between significant digits, right? Remember, anything that's not zero is always significant. So it's written between the 7 and the 1. So those two zeros are significant in this case, right? So every digit in this number is significant. So in this case, I have 1, 2, 3, 4, 5, right? So the 2, the 7, the 0, the 0, the 1. So I have 5 significant figures. I'll just abbreviate as sig figs. So 5 sig figs. What about this? Let's say I have 2003, right? So 2003. Again, those two zeros are written between, right, two digits that we know are significant. The 2 and 3 are definitely significant. So this would be an example where I have 4 significant figures. What if I have something like this? What if I have 7,800? In this case, it really is unclear. So I'll say it's unclear. There could be just 2 significant figures, just 7 and 8. There could be 3, or there could be 4. So there could be either 2, 3, or 4 significant figures. Usually, if you're not told any other information, you would just say in this case that there's just 2 significant figures. So you would say in this case there's 2 sig figs. You would not say that those zeros are significant. So just the 7 and 8 are significant. Sometimes what people will do is they will put a bar over like the last significant digit. So in this case, this would be 3 significant figures. Or if I put the bar over the last 0, then that would indicate 4 significant figures. Now, a better way to do this, and I'll show this in a little bit, is to use scientific notation. So scientific notation will make this clear as to how many significant figures 7,800 really has. Okay, so I'll write that here. Scientific notation will make this clear. Okay, let me go back to the handout and give you the remaining few rules here. Okay, so rule 5 says, when multiplying or dividing several quantities, the number of significant figures in the final answer, right, so in the result, is the same as the number of significant figures in the quantity having the smallest number of significant figures. So you always round the result to the number that has the smallest number of significant figures, okay? So that's for multiplying and dividing. Rule 6, when you add or subtract quantities, then the number of decimal places in the result should equal the smallest number of decimal places of any term in the sum or difference. Okay, so you're basically rounding to the least significant digit in that case. All right. And in number 7, we already talked about, right? In some cases where the number of significant figures is ambiguous, then using scientific notation can help remove this ambiguity, like that example that I just gave with the 7,800. Okay, so let me go again back to the iPad, and I'll give you some examples of all of these. So multiplying, dividing, adding or subtracting, and then an example of using scientific notation. Okay, so for example, let's say I measure the distance that something travels to be 12.74 meters. And let's assume I measure the time for the object to travel to be 2.3 seconds. So if I want to calculate the speed of the object, so this S here means speed, then we'll learn, if you don't already know this, we'll learn this in a little bit when we talk about kinematics. that speed is equal to the distance divided by time. So in this case, I'd have to take 12.74 meters and divide it by 2.3 seconds. And if you do that, you're going to get this answer like 5.5391304 meters per second. But obviously, that is not the way you want to write the answer. You don't want to write that because what that's saying is it's saying that the answer has, let's say, 1, 2, 3, 4, 5, 6, 7, 8 significant figures, and we know it doesn't have 8, right? In fact, remember the rule when you're multiplying or dividing is you have to round the answer to the quantity that has the smallest number of significant figures. So the distance here has 4 significant figures. The time has 2 significant figures. So I have to round my answer to 2 significant figures. So the way you should write this is it'll be 5 point, and we use the usual rules for rounding, right? If I look to the right of the 5 here, it's a 3, which is less than 5, so I just keep that as a 5, and everything else drops off. So it'd be 5.5 meters per second. That would be the correct answer. So in this case, the answer has 2 significant figure, right? 2 significant figures. Because that was the least number of significant figures that was in any of the quantities here, right? The time only had 2. Okay, as another example, let's say that I'm giving the mass, I'll write that as m, of an object to be 2.34 kilograms, and I'm given the acceleration of the object to be 32.11 meters per second squared. And I want to compute the net force acting on the object. I'll just call the net force F. Now, again, this is something you'll learn later when we talk about Newton's laws and kinetics. Well, it turns out that the net force is equal to the mass times the acceleration of the object. So in this case, I'd have to take my mass, 2.34, multiply by my acceleration, 32.11. And if you do that, your answer is going to be, if I just do this on the calculator, I'm going to get 75.1374. But again, I can't keep all those digits, right? I have to round to the correct number of significant figures. So in this case, the mass has 3 significant figures. The acceleration has 4. So the least number between those two quantities is the 3 here, right? So I need to round my answer to 3 significant figures. So this would be 75.1 in this case. And by the way, it has units of newtons, right? If you multiply kilograms times meters per second squared, that turns out to give you a unit of newtons. So that would be 75.1 newtons. Okay, now let me give you a couple examples with addition and subtraction. So let's say I'm adding 2 distances again. Let's say I have 2.001 meters plus 3.13 meters. Okay, so I add these like I normally would, right? So I have a 1, a 3, a 1, and a 5. But again, I can't keep all those digits. Remember, the rule for addition and subtraction is you have to round it to the smallest number of decimal places in either of the numbers. So in this first number here, there's 3 decimal places. In the second number, there's 2 decimal places. So when I round this, I have to round this to 2 decimal places. So in this case, the answer would be 5.13 meters. Okay, so it really depends on the decimal places now. The smallest number of decimal places, that's what you want to round it to. And then if I have subtraction, by the way, another way of saying this is you want to round it to the least significant figure here. So, which in this case is the hundredths place, right? Because this goes all the way to the thousandths place. This is the hundredths place. You want to round it to the least, which is the hundredths place, right? Which is the same as keeping the smallest number of decimal places. Okay, same thing for subtraction, right? So if I have let's say those are my values that I want to subtract. Again, we can say that they're meters or something. Let's say their distances meters. So I would go ahead and do this subtraction, right? So this is going to be 1, 3. I need to borrow, right? So this is 8, this is 1, this would be 9, and then 1. But again, I can't keep all of those digits. So what do I round to? Well, it looks like in this case that the number with the smallest number of decimal places is 7.2. So I need to round this to 1 decimal place. So this would be 1.9 meters. So in this case, I rounded to 1 decimal place. Okay. And that's basically the rules that you will need to know. Let me give you one more example. What if you have something like this? What if you have like, say 3,200 plus, so now I have no decimal places. And then, I don't know, 120. I'll even do 125. Okay, 125. So 3,200 plus 125. So if I just add this out, right, this will be 5, 2, 3, 3. Now again, this depends. If we assume that 3,200 only has 2 significant figures, because it could have 2, it could have 3, it could have 4. But let's assume it only has 2. Then if you look at all these digits here, the digit that's the least significant is a 2 here. So I'd have to round to like the hundredths place. So in this case, the example, this would be rounded to 3,300. And that would be the answer, right? Because I have to round to the least significant digit. Now, you won't see this very often, and I'm not going to be super picky about this particular example. Like if you gave me 3325, that would be fine. But whenever you have decimal numbers, then you do want to make sure you do this correctly. You want to make sure that you round it to the number with the least number of decimal places. Okay. And then the last thing I wanted to mention is just how scientific notation can remove the ambiguity in some of these numbers as to the number of significant figures. So remember last time we looked at this number here of 7,800. And we said it could have 2 sig figs, it could have 3, it could have 4, depends. But if I write this in scientific notation, right? So remember, to do that, I have to move the decimal, in this case, 1, 2, 3 places to the left, right? Because it has to be a number that is greater than 1 and less than 10. Basically a digit and then the decimal point. And then since I moved it 3 places to the left, I write this as times 10 to the third. Well, if I wrote it like that, what I'm saying is that this number has 2 significant figures, right? Just these 2 digits there, the 7 and 8 are significant. However, I could have written it like this, right? I could have said this is 7.80. And again, it's going to be times 10 to the third. In this case, I'm implying that the number has 3 sig figs. Or if I wrote it at 7.800 times 10 to the third, then I'm saying that all 4 digits are significant. Okay, so you could use scientific notation to remove that ambiguity to determine exactly how many digits are significant. Okay, a few more examples. So how many significant figures are there in this number? And I'll write it in scientific notation. Okay, so if you look at this number, right, we only have to look at the actual number here. We don't have to look at the power. We don't have to look at 10 to the minus fifth, just this number. And since I wrote it out as 3.70, all of these are significant. Right? Remember, a 0 to the right of the decimal after all the numbers is going to be significant. So this would be an example where you have 3. There's going to be 3 sig figs. And by the way, if you wrote this number out in its standard form, right, how would we do that? Well, we'd have to move that decimal point 5 places to the left. So it would be basically 4 zeros and then 370. So again, there's all 3 of these. You can see it more clearly here. All 3 of these digits are significant, right? But these zeros that are in front, these are just placeholders. Those are not significant, but that last 0 is. So that would be 3 sig figs. Okay, and then one more example. Let's say I have this large number, 59000 00, right? So what is that? 5,900,000. And let's say I write it as 5.9 times 10 to the 6. So how many significant figures would there be based on how I wrote it? Well, because I'm only writing 5.9, it's going to be 2 significant figures. So this would be a case where we have 2 significant figures. Okay, so hopefully that made sense. And we'll do more examples. There'll be more examples in class. Thanks.